This is a very short video, just meant to explain what we mean by the root mean square value of a sinusoid. In the last of the week 12 lectures, we were talking, among other things, about the average powers of the various terms in the Fourier series. For n equals 0, where the corresponding term is a constant, namely a0, if we're talking about the real valued version of the Fourier series. For that constant term, we just had a0 squared. If we have a DC signal, for instance a DC voltage, then the corresponding power is proportional to the square of the voltage. But we saw that for sinusoidal terms, a sinusoidal term, for instance, with an amplitude of a sub n, in that case the power is 1/2 an squared. So we have to treat sinusoidal signals differently from constant signals. And sometimes we would like to avoid having to do that. We'd like to be able to treat sinusoidal voltages, for instance, the way we treat DC voltages. And in order to do that, we sometimes replace the amplitude with the so-called root mean square value. And this is abbreviated, of course, to RMS. So if we have a sinusoid, for instance, with an amplitude a sub n, we simply divide that value by the square root of 2. So that way, the average power in the signal is simply the square of the RMS value of the signal. So we have this convention of often using the RMS value of a sinusoidal signal so that when we need to compute powers, we can do it as we do for constant signals, or for DC signals, if you like. So for instance, as you know, the power that we have in our places of work and residence is typically 120 volts AC. This actually refers to the RMS value of the voltage. So in fact, the peak value is 120 volts times the square root of 2, which is approximately 170 volts. So the sinusoidal voltage in our household electrical outlets has actually an amplitude of about 170 volts. The 120 volts that we commonly use is the RMS value. So if you were to connect a great big resistor, say, to the household supply, the power dissipated by that resistor would be 120 volts squared divided by the resistance in ohms. You wouldn't have to worry about that factor of 1/2 because the sinusoidal voltage has already been expressed as a root mean square value. And that's all I had to say for this little video. I'll give another couple of videos that likewise sort of tie up some loose ends.